Hi guys, we're going to start section 5.5, solving polynomial equations, which today we're just going to work on factoring. Why don't you take a second to pause the video and see if you can factor these using the skills that you already know. If you look here, you'll see that I have factored these. These are all quadratic. The first one, I just found the GCF, or the greatest common factor, and factored it out. The second one, we had difference of perfect squares. So square root of x squared is x, square root of 9 is 3, and one with a plus and one with a minus. This one is prime because there's no possible way to factor it. Again, here, difference of perfect squares. The square root of 25 is 5, the square root of x squared is x, the square root of 64 is 8, the square root of y squared is y. One with the plus, one with the minus. And then on this final one, I said what two numbers add up to -1 but multiply to give me -12, and I got -4 and 3. So what we're going to talk about today is called sum and difference of cubes. One second. One thing you need to recognize about sum and difference of cubes is what is a cube. A cube is something to the power of 3. So 1 to the third is 1, 2 to the third is 8, 3 to the third is 27. I wrote all these numbers all the way up to 10 to the third, which is 1,000. There's a formula here for a sum of cubes and a formula for a difference of cubes. I'm going to show you how to use those formulas in order to factor. First, there's a list of factoring techniques that you might want to recall. If you have any number of terms, you can always use GCF, or greatest common factor. If there's two terms, check out difference or sum of cubes, which is what we're going to learn today, or difference of squares, as well as GCF. With three terms, if it's quadratic, try the trinomial pattern, which we've used it before. What two numbers add up to b and multiply to AC. And if there's 4 or more terms, then we're going to use grouping. So here's the first one that we're going to do together. Whenever I'm factoring, I always want to check first for a greatest common factor, or a GCF. So looking at this one, I noticed that both of these numbers are divisible by 2. And they both contain at least one x. So I would say that the GCF is 2x. So let's see what I get after factoring out that GCF. I have 8x to the third plus 27y to the third. Looking at that, now that I have factored out that GCF of 2x, I noticed that this 8 is one of those perfect cubes, and that 27 is also one of those cubes. What we have here inside the set of parentheses is a sum of cubes type problem that we're going to use the formula for. I'll write the formula up here. A to the third with this formula, I'm going to give you a little trick to kind of remember the order of the signs, because that's really the only thing that's different about the two equations with the sum formula and the difference formula. For the signs, I just use this acronym called SOAP. The first sign is the same as whatever you were doing, so the sum of cubes, it's a plus. The second sign is always the opposite sign, and then the last sign is always positive. So when I'm looking at what I have here, 8x to the third, I'm thinking I could really rewrite that as 2 to the third, x to the third, which would give me 2x to the third power. Similarly, with this one, 27y to the third, I could rewrite that as 3 to the third, because 3 to the third is 27, y to the third. So that's 3y to the third. So basically what I'm telling you is, if I have a to the third, and that's equal to 2x to the third power, that would mean that a is just 2x. And then if I have b to the third, and that's 3y to the third, that would mean that b by itself is just 3y. Once you figure out that part, then all you would have to do is plug it into this formula and of course simplify a little bit. So I'm going to plug it into this formula. All right, if you notice, I plugged in 2x and 3y into my formula, and now I'm about to clean it up just a little bit. So I have the 2x plus 3y. And I'll have to remember something. What is 2x squared? So 2 squared x squared, that's going to give me 4x squared. And then minus 12xy plus 3 squared y squared, that's 9y squared. And the last thing I don't want to forget about is this 2x that was over here originally in the beginning of my problem. There I have my answer. All right, I'm going to give you a minute. You can try this one on your own. It's really similar to one that we've already done, so I'm not going to pause here, but I'll give you time to try that one on your own. All right, this example 3 is the next one we're going to do together, which I want to notice if it has a GCF. I noticed that it has a GCF of 5y. So if I take 5y out, I'll be left with y to the third, and I'll do this, and I can leave it like this for now. Y to the third minus 64z to the third. So I want to take a minute to figure out, hey, what is A going to be and what is B going to be? I noticed that again, this is a set of cubes, but this time it is a difference of cubes. And I'll write down the formula in a minute, but I want to figure out A and B. So A, this one's really straightforward because I could technically say that that's 1y to the third, or 1 to the third y to the third. So just y to the third. So I would say A is just y. And then for this second part, what to the third is going to give me 64. That's 4 to the third, z to the third. So I would say 4z to the third. So B is just 4z. So I'm going to write down the formula for a difference of squares. Okay, so this is the formula for a difference of cubes. I believe I said difference of squares just a second ago. So difference of cubes. I'm going to go ahead and plug in A and B into this equation here. So I'm going to just set it up. I'm going to have A minus B. A is y and B is 4z. And then in my second set of parentheses, I'm going to have, let's see, how can I write this? I'm going to have A squared plus A times B plus B squared. So let's see. A squared is y. Then I have a y. And then B is 4z. 4z. All right, all I'm going to do is clean it up a little bit and not forget my 5y that was in the beginning. So I have 5y, y minus 4z, y squared plus 4yz plus 4 squared, z squared is 16z squared. There's my final answer. What do y'all think? I want you to try this next one on your own. Example 4. First, see if there's a GCF, and then try to factor it using sum or difference of cubes, depending on which one you need. All right, check it out. See if you got the same answer that I got. All right, if you have questions, let me know.